Steve Torchinsky is program scientist for space astronomy with the Canadian Space Agency on the South Shore. He joins me today to talk about himself and about being an astronomer and gazing at the stars. Good morning, Steve.
Good morning.
Thanks for coming in. Let me begin with you. How and when did you decide to become an astronomer, young man like yourself? Mom, I want to be an astronomer. I don't want to be a lawyer or a doctor. I want to be an astronomer.
I don't think I told Mom until much later.
What got you interested in that?
Well, I was interested in science fiction, I guess. Like a lot of us, we start that way, interested in space and the romance of space. I read all the books in the library after the recommendation from our librarian that she said, you might like this, so read it, and I did. And ever since that time, I guess I was 10 years old or so, I've always been interested in space and sort of focused the rest of my education in that direction as much as I could choose when high school and Cégep, university.
And you studied what at university? Astronomy?
As a matter of fact, I didn't. I studied mechanical engineering at university. And so it was a bit of a side trip from my goal to be an astrophysicist. I studied engineering and afterwards went to do postgraduate work in astronomy.
And this was done where?
Edinburgh in Scotland.
Oh, interesting. How long did you spend there?
4 years.
So back here, did you join the Canadian Space Agency immediately thereafter?
No, it's been a while since I left Montreal after my engineering degree. I went to Scotland for 4 years and different positions around the world. I spent 3 years in Ottawa at the National Research Council, and I was nearly 5 years in Sweden at Chalmers University of Technology, and then back to Canada at Calgary, the University of Calgary, and finally now back to Montreal at the Canadian Space Agency.
So you've cast a wide net then. You bring quite a bit of experience back home now at the Space Agency. You are the astronomer for the Space Agency, right?
Yes, and we hope that will change sometime in the future. We want to hire at least another astronomer, but many people think it's odd that the Space Agency is all about space and there's only one astronomer on staff.
It is rather odd.
Yes.
Now, perhaps we can cover off a bit on what the agency does, because many have the impression that it's Marc Garneau and people in orange suits, and that's it. There's much more to it than that, isn't there?
That's true, yes. The astronaut program is a big portion of the Canadian Space Agency program, but there are other branches, and we're pursuing scientific experiments as well, and quite a few astronomy experiments, but also studies of the upper atmosphere, the aurora, and exploration of the solar system.
Now, space astronomy is a distinction that is specific here because you essentially, if I understand correctly, observe space from space as opposed to observing it from telescopes on the ground here.
That's right.
Okay.
There's one very important reason for putting a telescope in orbit around the Earth, and that's to get above the Earth's atmosphere. When you see the twinkling of a star, that's because of the Earth's atmosphere, and maybe it doesn't bug you so much, but it will bother the sensitive...
Doesn't bug me much, Steve.
It doesn't?
No. But it bothers you, doesn't it?
Yes.
Hubble. Have you been exposed? Have you had a chance to see the latest images? Of course you have.
Of course, yeah, every day.
Quite impressive, aren't they?
They are, yes. Hubble has been an enormous success and has brought many great images to Earth and new discoveries.
Tell me about the programs you're working on here at home.
Well, we have a number of projects, and right now there are 2 satellites in orbit for astronomy that have Canadian hardware on board, one of which I was personally involved in for a number of years while I was in Sweden, and that was called Odin. Odin is unique because, in fact, it's not only astronomy, but it's also atmospheric science. It's studying the Earth's upper atmosphere and monitoring ozone and carbon monoxide in the upper atmosphere.
And we contributed to this project how?
On the atmospheric side, we contributed the main instrument for monitoring the ozone. On the astronomy side, we contributed part of the radiometer receiver instrument, and we also provided manpower, which in fact was me. The Canadian Space Agency supported my being in Sweden for 5 years to help put together this instrument.
And this is a loft now, is it?
It is. It's been aloft for 2 years, since February 2001.
Still sending back data?
Yes.
Do you check that every day, or do they page you at home, or how does that work?
I haven't been checking every day, but we have a bunch of papers coming out in a month or so. There's a dedicated issue of Astronomy and Astrophysics, one of the main astronomy journals. And there'll be 11 papers that are all based on results from the Odin satellite. And you have other long-range projects that you're working on right now? Yes. The longer term we're working on with the European Space Agency a satellite called Herschel, which is similar to Odin, but will explore a wider range of wavelengths and also look deeper into space. So Odin is more concerned with the chemistry of clouds that are forming stars, but here in our own galaxy. And Herschel will do similar things, but will also be probing external galaxies.
And this is named after whom?
Herschel is named after William Herschel, who was the man who discovered infrared radiation. He did that in 1800. And there's another one called Planck. Yes. Named after, I happen to know this. Are you impressed? Max Planck, I presume. That's right. Right. Max Planck. And that will be investigating what exactly? Well, the Planck is also a European Space Agency mission with Canada involved, as well as a number of other countries. And its main goal is in cosmology to study, well, the fundamental parameters of the universe, the age, the geometry, and to say something about the eventual future of the universe, and also when stars were formed in the past. And who was Max Planck? Max Planck, well, was one of the great scientists of the 20th century, late 19th century, who, among other things, described black body radiation. And black body radiation is thermal radiation. It's in a particular way that Max Planck described. And the reason we call the satellite Planck is because it's going to be measuring the cosmic microwave background, which is the most ideal black body radiation that's ever been measured. Okay, black body, is that like the black energy and the dark matter is all the same thing? No, that's something else. It has a nice name, black body, but it's not quite so esoteric as dark energy and dark matter. Okay. It's something a bit more ordinary, day-to-day life. It's thermal energy. That means it doesn't radiate in one particular color. It radiates in all the colors of the spectrum, and it falls a particular amount of intensity, which is the temperature. We call that temperature. Is this fun for you? Do you look forward to this, or is it frustrating because there's so much to do in so little time? Well, it's fun. All the science part is fun. The frustrating part comes when we're trying to build these things, and with limited budgets or limited time scales. That's where the frustration comes in. Never in the science. It's always exciting. You know, even when you don't know something, you know that you have a chance to understand in the future, and you could plan new experiments. That's always fun, even when you don't know something. What do you say to people who say, we should be spending our money on things down here? Well, we're doing something that's beyond the day-to-day business of life and living. We're looking into the far future, into things that go beyond, I got up this morning and I had breakfast. We're looking at the origin of life, the universe, and how was the solar system formed, and where did all these heavy elements come from that formed molecules that formed life on Earth? And why is it that we're here in such hospitable circumstances? Why did the Earth form here? Why is it so perfect distance from the sun and so well protected by its atmosphere, just the right amount so that life could take hold here? And also even much bigger questions like the universe itself, the whole very biggest picture. What's the nature of the universe? is it infinite? And if it's not, what's the shape of the universe, or what will happen ultimately to the universe?
So what do you dream about? Jogging through the planets? And
Well, vicariously, I dream about the being there, but through the telescopes and through the observations. I don't actually think anymore about going out into space to try and test these places out.
That's not something that you'd like to do? To get out there yourself?
No, it's too dangerous.
Steve, thank you very much for coming in this morning. I appreciate it.
My pleasure.
Steve Torczynski is program scientist for space astronomy with the Canadian Space Agency. And he's a nice